Bismillahirrahmanirrahim. Dear students, आज हम इस क्लास में बात करेंगे अबाउट द वोल्फ-किश्नर रिडक्शन रिएक्शन. ये भी एक इम्पॉर्टेंट रिएक्शन है एज फार एज योर ऑर्गेनिक केमिस्ट्री इज कंसर्न. जैसे हमने लास्ट क्लास में देखा था क्लेमेंसन रिडक्शन. Now this is also the similar type of reduction regarding the carbonyl compounds. Now as we can see here, we have an aldehyde or a ketone. That aldehyde or a ketone gets converted to this alkene. That means this carbonyl CO group is getting converted into the CH2, that's methylene group. So same was the result in case of the Clemmensen reduction. The difference is that here we are using hydrazine and a strong base like potassium hydroxide in presence of some, we have to heat this. Whereas in case of the Clemmensen, what we used was the zinc amalgam in presence of concentrated HCl. So let's move about this reaction. So this is basically the Wolff-Kishner reduction reaction. So it says that in this reaction, a carbonyl compound, whether it is aldehyde or a ketone, is reduced to the hydrocarbon. तो basically यहाँ पे हम क्या करते हैं? If you have any carbonyl compound, aldehyde or a ketone, that is, it contains C double bond O, so that can be converted to CH2, that is methylene group. Or we should say जो नया compound बनेगा, that's your hydrocarbon. So you can see here. So in this method, a carbonyl compound is heated with a mixture of hydrazine. यानी जो हमारा carbonyl compound है, whether it's aldehyde or ketone, we heat this with hydrazine, that's NH2, and a strong base. For example, here it is shown potassium hydroxide. You can use sodium alkoxide base, potassium tertiary butoxide base, and so on. So it should be a strong base. So what is the result? When we heat this at a temperature of around 450 Kelvin, so this is very high temperature, in a solvent like ethylene glycol. Okay? You can see here aldehyde ketones gets converted to CH2. That is, this is no new compound formed is alkane. It's a hydrocarbon. But with this there is release of nitrogen gas. Now इसको पूरा understand करने के लिए इस reaction को, it's always important to look into the mechanism, and this is the mechanism that gives you the vision to solve the numerical problem in any exam, particularly in the competitive exam. Now let us start. So this is our carbonyl compound. So we'll start with our carbonyl compound. R1, R2. So it depends R, if R is an aryl group, if it is benzene, then it can be an aromatic ketone, and then accordingly, depending on R1 and R2, our compound can be aldehyde or ketone. So in general, it's a carbonyl compound, let's say R1, R2. So in this step number 1, it reacts with hydrazine. This is your hydrazine. Now we know that this carbon in the C double bond O, we have this pi bond present, and this is your sigma bond. Since oxygen is highly electronegative, so this pi bond is towards the oxygen, so there is partial negative charge. This carbon has partial positive charge, this carbon. Now, so we have this nucleophile present, that's hydrazine. It contains a lone pair of nitrogen. So nitrogen compounds, containing compounds, they usually act as bases, Lewis bases, because they can donate that lone pair. So you can see here the attack on this carbon. So result is that ये जो आपका pi bond था, it moves completely towards this oxygen. So complete movement towards this oxygen. So what we got? R1, R2, negative charge on the oxygen, and then this is NH2, NH2. Since nitrogen has donated a lone pair, so we have a positive charge here. So this is what is formed after the attack of hydrazine on this carbonyl compound. उसके बाद क्या होता है? Oxygen is a negative charge, ठीक है? So this will take the proton easily from the medium. So what it forms OH. So this is the new compound. Now in addition to this, since this nitrogen has a plus charge, हमने इसको बहुत बार डिस्कस किया है, जो हाईली इलेक्ट्रोनेगेटिव एलिमेंट्स होते हैं या एटम्स होते हैं, they are not stable in a condition where they have a positive charge. So somehow in the compound they will try to get stabilized. For example, in this case, let us show it here. This was hydrazine, NH, NH, and then this is the other part, NH2, this one. So this has positive charge, this nitrogen. So this will get stabilized by any of the hydrogen atoms. And ये bond, this bond pair will move towards nitrogen, so this gets minimized and hydrogen is lost as H+. So this is what is formed in this step, alcohol compound. Then the next step, since this reaction occurs under the basic conditions, यानी हमारा जो medium है जिसे हम reaction करते हैं, that contains strong base like potassium hydroxide. So we have hydroxide ion is present. Now, hydroxide ion, they take the proton from this nitrogen. Now this point also we should keep in mind that if our compound contains groups like amine, that is NH functionality, or OH groups, they are considered to be the acidic, that is they can easily donate this H in the form of H plus in presence of base. यहाँ पे हमारी medium में base present है, hydroxide ion. So we have this NH group here, we have this OH group also. So this NH is released as it's released as H plus. So result is that when this H plus is lost, along with this group is also released as OH negative. So this OH negative and H plus, they are released as water. The result is that जो negative charge यहाँ पे आया, that will move to this position. Why? Because this hydroxide group is lost, जो हमने यहाँ पे दिखाया है. So result that you will get this compound NH double bond. So we have double bond here now, NH2. So this is this compound which is formed, it's called as hydrazone. So amine compounds, they react with the carbonyl compound, they form the ship bases. But when it is hydrazine with the carbonyl compound, the new compound formed is hydrazone. आप इसे generalize भी ऐसे कर सकते हैं याद रखने के लिए. This is our carbonyl compound. So reaction of this carbonyl compound with hydrazine. This is our hydrazine, NH, and this is NH2 on this side. Simply remove this water molecule from here. So what is formed? C double bond N, NH2. So this compound is called as the hydrazone. Same is the case here, C double bond NH2. So this is your hydrazone. So in the first step, hydrazine reacts with the carbonyl compound to form hydrazone. Now in the next step, as usual, now there's NH2 is present also. We have this nitrogen also. This is more acidic. The hydrogen atoms attached to this nitrogen are more acidic. That means they can be released as H plus in presence of base. क्योंकि medium में हमारे पास base present है, hydroxide ion. So hydroxide ion, they will take a proton from this side to form water. This is minus water. So result is this is NH negative, NH double bond R1 R2. Fine. Now in presence of this anion, this bond pair comes between this N and N. Q? Because this pi bond moves towards this carbon. So what that does, I will show it here in this step what is formed. You have this type of species formed, negative charge on this carbon. We have NH. This is double bond N and H. So result is that we have a negative charge on this carbon. ठीक है, same is the case here. इसने step दिखाया नहीं यहाँ पे. So I have drawn it here. So as this carbon gets negative charge, now it can take proton from the medium. We have water molecules in the medium. We have used the base which is prepared in the solution, is prepared in water. So it takes a proton from this water, this carbon. So give this carbon a proton. So result is that it becomes this compound. R1, R2, H, N double bond N, and then NH. Now we have hydroxide ion present in the medium. This one is also released because this is acidic. Once this gets released, it gets a negative charge. ठीक है. जैसे ही इस पे नेगेटिव चार्ज आ जाता है, so what happens, this bond moves towards this and nitrogen gets plus, so this negative and this plus, it forms N triple bond N. So N triple bond N is basically your nitrogen gas, structure of nitrogen gas. So N triple bond N is your nitrogen gas, so you can show it, nitrogen gas is released, N2. तो result क्या बना यहाँ पे, I have shown it here, so this is released as nitrogen gas, ठीक है. So this gets a negative charge, this carbon. So as this gets a negative charge, you can show it, it is here. मैंने इसको पहले ही यहाँ एक ही स्टेप में कर दिया. So you have this compound formed, which is again a carbanion because this carbon has a negative charge. As usual, it will take a proton from the water. So we have our final compound formed, which is hydrocarbon. That means this portion we have CH2, whereas in our parent compound, in our substrate, it was C double bond O. So result is that your C double bond O group has got converted to the CH2 group, or I should say carbonyl compound is converted to the hydrocarbon. So this is similar to what we have in the Clemmensen reduction. वहाँ पे भी carbonyl compound gets converted into the hydrocarbon, that is CO group gets replaced by CH2 group. Difference is that in the Clemmensen reduction we use zinc amalgam and concentrated HCl, while as in Wolff-Kishner reduction we use hydrazine and a strong base like, let's say, potassium hydroxide, and also we have to heat this solution. So this is all about the basics of your Wolff-Kishner reduction reaction. So ये दोनों reactions बहुत important है from the examination point of view and also from the competitive examination point of view. So we'll move back. So what we have discussed is Wolff-Kishner reduction, that is conversion of carbonyl compound into the hydrocarbon, where we replace the C double bond O by CH2 group, that is methylene group, in presence of hydrazine, by the help of hydrazine and base, and also we have to heat this. So importantly चीज जो इस reaction में है that there is release of nitrogen gas. So gaseous product is released. That we should say the entropy of the system is increasing thermodynamically. जब entropy increase होती है, that becomes a driving force for the reaction to occur. That is, this is thermodynamically feasible reaction. Now इसको आप understand करने के लिए, if you want to further try to read this, so I am attaching a PDF note in your description of same presentation, concise note, so you can please download that and you can study for the examination purpose. Also, certainly if you have any confusion anywhere, so please write down in the description, in the comments. So inshallah we'll get back to you, or you can also write down on my number. You can communicate through the WhatsApp 8491 85 7406. Please just write down that the clarification regarding Wolff-Kishner reduction. So this is all about the basics about the Wolff-Kishner reduction. There are some few more points which one can discuss about Clemmensen versus Wolff-Kishner reduction. So probably I will make a separate class on this, a very short class of 5 to 10 minutes, where we have the comparison between Wolff-Kishner and Clemmensen reduction and other important things, particularly from the competitive examination point of view. So this is all for today. Thank you.